For RCR TV, I'm Sean Kinney, and welcome to HetNet Happenings, where we take a look at all things DAS, Wi-Fi, small cell, and much more.
CommScope, thinking beyond today's technology to help you make the best decision for your network and your business. Telecom Careers, the #1 global telecom and wireless job board, telecomcareers.com.
Welcome back to HetNet Happenings. We've got a great show for you this week. Our guest is Yann Le Helloco, the Chief Technology Officer for InfoVista. We're going to talk about network planning and optimization solutions, among other topics. But first, I wanted to take a look at a few headlines. We talk a lot on this show about distributed antenna systems. DAS is a key technology for bringing cellular capacity indoors, particularly at large venues. On that note, RootMetrics recently analyzed the coverage at Kauffman Stadium, home of the Kansas City Royals, and very near Sprint headquarters in Overland Park, Kansas. RootMetrics found that Sprint Stadium Cellular has the fastest download and upload speeds of the four major carriers. Sprint also scored 100 out of a possible 100 in terms of reliability at the stadium, putting it significantly ahead of its closest competitors. More Sprint news out of Chicago. The carrier has increased its investment in the city both in terms of dollars and jobs. Company will add 750 new jobs in addition to the 300 already announced, as well as invest $150 million in its Chicago area network by the end of 2015. Another big story, this one involving Apple and Cisco. Just 13 months after announcing a partnership with IBM, Apple's teamed up with Cisco to continue pushing its iOS operating system into the enterprise space. Both collaborations are meant to tailor enterprise offerings for Apple devices. In this case, Cisco is pledged to optimize its networks for iOS-based devices. By partnering with Cisco, which provides networking gear or services to 95% of the Fortune 500 companies, Apple hopes to gain a more legitimate foothold in the enterprise as opposed to bring your own devices being backdoored into the network. For Cisco, the deal solidifies a mobile strategy that's long been a top priority for the company. For more on those stories and many others, I'd encourage you to check out rcrwireless.com and be sure to subscribe to our daily e-newsletter to have the latest telecom and ICT news delivered straight to your inbox every day. Now I'd like to introduce our guest, Yann Le Helloco, the CTO of InfoVista. Yann, thanks so much for joining us, and for the folks at home who may not be familiar with InfoVista, can you give us an overview of the company and tell us a little bit about your role?
InfoVista is a company that has been around for quite some time, actually. Got founded in 1995. It has roots in many different businesses, though in the mobile business, which is what we're interested in. We have roots in the old MSI company, used to be a UK company, created the first radio planning tool, Planet, which is still around and which we still have. We have roots in Ericsson. We rebuilt the Planet software from Ericsson, and subsequently also acquired the planning business from Ericsson, Thames Cell Planner. We have roots from Mentum, which is the company that did that acquisition, and from IXU, a Malaysian-based company focusing on network optimization. Today we are a very fast-growing company, a worldwide organization. We have more than 1,300 customers, I believe, in more than 150 countries. So pretty sizable companies, and we were in the fields of service assurance. We're a leader in service assurance, application performance guarantee with a recent acquisition of the Panama Technologies business. And we are, of course, in the mobile planning and optimization business, which is the focus of this discussion today. My role within the company, I manage all the R&D activities on all those different axes, and I really drive the technology strategy and leadership of the company, mostly focusing on our customers, needs of our customers, and bringing innovation to them.
Yann, small cell rollouts are a really hot topic right now as carrier deployments are finally starting to catch up with projections. From my perspective, this current emphasis based not just on the need to densify networks and add capacity, but also a function of the fact that the hardware and software is really at a point where it can support these large-scale rollouts. What are your thoughts on that?
Evolution of networks towards being more softwareized, towards being denser, and wireless in general is really at the edge of that nervous systems of our economies, our societies that we're building today. And the more we go into that direction, the more we have a need for capacity, for proximity of that cell edge of the network in general. And this is at a very high level what drives the needs for small cells. Now, there are different ways to bring capacity. One way, obviously, is to get more spectrum, but I think we all know that this is very expensive and spectrum is limited. We can use more antennas to leverage various capabilities like spatial multiplexing, beamforming, and so on, but that has its limits as well. We can use higher modulation encoding schemes, but that has limits as well. And in the end, we need the small cells simply to be able to reuse the spectrum more in the spatial domain. So and there's no way to really avoid densifying the networks with that in mind. And even if we are to go with more spectrum, we are going to go into the higher bands of the spectrum, and higher bands means less propagation, more path loss, and that means smaller cell radiuses. And once again, we have another driver for densifying and having small cells. So in general, whether it's to bring capacity or to fill in coverage hole or to bring coverage inside the buildings, there's no way to avoid going towards small cells. And that, I think, is why we're seeing those evolutions. Now, deploying small cells is not easy. I think many operators have started that process. Some of them are more mature than others, and they have all seen challenges. A few challenges I would note is, first, because typically small cells are deployed within the same band as the macro cells, you have interference. You have to deal with those, and it's not easy at all. You can just plunk cells, hoping the technology will deal with the interference, but it doesn't work this way. You have to actually design your small cell deployment in a way that you minimize interference and therefore optimize capacity. If you don't do it, you can actually do bad to your network. You can just inject interference and destroy its existing capacity. So it can be very negative. Second challenge, I guess, focusing on LTE, is that technology had to evolve to enable that interference management. We've seen ICIC, we've seen eICIC to enhance it. We've seen FE ICIC for further enhance ICIC, and all those evolutions clearly demonstrate the need for technology to enable those HetNet deployments. And today, we are reaching a point where I believe the technology is actually getting mature enough to really work and to really enable those deployments. And so finally, I would say that there are a few other issues that come with small cell. We know that backhauling is a challenge. Operators need to find ways of doing it. There are various ways. You can use fiber, you can use microwave, possibly microwave. You could also use different kind of small cells, those relay nodes. Relay nodes are interesting. They are basically small cells from a UE point of view, but they also act as a UE from a macro cell point of view, and that might be a suitable way for many operators to backhaul those small cells. There are lots of different ways of doing it, and that's a learning process. And I would say finally, and last but not least, really, I think operators have been facing difficulties in fine-tuning their ROI and really finding ways to maximize their ROI and maximize their efficiency in the way they are going about deploying and managing those small cells. And that's a learning curve. It's a learning curve that is big because in many cases that can impact their own organization, that can impact really the way they have so far dealt with the planning, the design, the optimization of the networks. That can have profound impacts on the way they go about dealing with their network in general. Many operators have progressed. You have mentioned Sprint. Sprint is one that has progressed a lot. They did a lot of work in that area. And I think all of that work eventually is going to benefit the whole ecosystem. We see lots of players like Teleworld, for example, that worked a lot with Sprint. uses our software for this kind of planning and design of small cells, and they build a lot of experience in doing this, and that experience can benefit a lot of operators.
And with these network deployments, service providers are focused on maximizing return on investment. Yann, how can planning and optimization solutions like those provided by InfoVista help facilitate that for clients?
A few topics to look into, I guess, before answering that question. And one would be to look at what are the goals of the operators when deploying small cells, because there could be many objectives. One could be simply a positive ROI objective, really trying to evolve their network in the way that he is going to produce margins. Simply, another way to look at it is to consider operators that want to deploy small cells in order to generate a competitive differentiator in comparison to their competitors. That can be a strategy for an operator. And a more standard objective for deploying small cells could be simply to add capacity, whatever it's going to be used for. In all cases, though, I believe a common factor is the objective that consists in minimizing the interference when you're going to deploy the small cells, especially when you deploy in-band and using the LTE technology. Because that is indirectly what is going to enable higher capacity in your network. And that is what is going to make sure that the quality of service that you're going to deliver to your subscribers is going to be there. In order to do that, there are a few things to consider. The first one is to minimize interference, you need to understand very well your surrounding macro cell network. You need to know your configuration, you need to audit your network, and you need to make sure it is ready itself to absorb the addition of a macro cell layer and a small cell layer on top of it. Just doing that work is not that easy, and we provide the tools for operators to understand their network, to understand its current performance, and to understand how they can go about densifying it. The other key input to proper design of small cells is to understand where your hotspots are, what your traffic distributions look like, what are the typical traffic patterns throughout the day that your subscribers are going through and that you have to serve with those small cells. And here too, we provide a range of solutions for operators to monitor live 24/7 all their calls, all their subscribers in order to build a very, very accurate understanding of where the hotspots are and where it is that they have to add capacity to the network. And doing so, we don't do it just in the traditional two-dimensional way. We acknowledge the fact that small cells have to add capacity not just at the street layer, and typically not at the street layer, but rather inside the buildings in the third dimension. In order to address this, we have a complete set of tools for operators to understand what's going on in the third dimension from a traffic point of view and eventually from a network performance point of view as well. And finally, knowing all of those inputs, you have to do your design. You have to make sure it works well to macro cell layer. You have to understand the interference patterns throughout the network. Basically, you have to design it right. And for this, we provide planning tools, Planet, typically, which is going to give the capability for the engineers to understand both their macro cell and their small cell layers and make sure they work well together. And down the road, once that's deployed, you need to monitor what's going on. You have just added thousands possibly of small cells. That's as many potential failures, as many potential problems, lots of new nodes to monitor, lots of backhauls. So we provide tools for the monitoring of that entire infrastructure, for the monitoring of the usage of that infrastructure and what customers, whether they are VIPs or not, are going to experience using that new layer of nodes. And we provide a tool for our customers to optimize as they go along their new small cell network together with their entire network.
Yann, you mentioned the business case associated with these carrier small cell rollouts. Can you please expound on that a little?
I guess that's the goal for many operators, to be able to really focus all of their investments where it matters, and to make sure that when they deploy those small cells, they deploy them right in a way that's cheap, in a way that maximizes the ROI, but at the same time in a way that is going to deliver all the value they intend to get from the small cells. There are a few steps in that process that I think are fundamental. The first step is really to understand your existing network, to know where are your holes, both in terms of coverage and in terms of capacity, and to understand what the demand is. To understand what the demand is an entire process on its own. There are different ways to go about it. You can analyze the traffic you are having, enjoying on your current network. That's one way of doing it, but to do this, you need to be able to geolocate it. It's not enough to know in what cell traffic is occurring. It's important to know where in the cell that traffic is occurring. So that is a very important input, and here we provide ways of geolocating all the calls, typically leveraging call traces to do that, and that geolocation goes in the third dimension and leverages technologies that allow for that geolocation to be extremely accurate. Because it's important to know in which building you are. It's important to know in which streets the traffic is actually happening. Because when you're going to go about deploying small cells, you're going to have to really target the right area and not miss it, not even by a couple of streets or by a quarter. It's not going to work well. You have to be very precise in doing this. Another way to go about understanding the traffic that is happening in your network is to use social data. You could use like Twitter-like data to understand what the patterns are by simply studying where data usage is happening throughout the market that you want to cover. That's another very interesting input, and it can lead to very interesting results, typically in areas where you have dense traffic happening. Another way of understanding traffic is to leverage the knowledge of the geographic area, geodata, 3D building databases with an understanding of what building is what. So there are lots of ways of going about that, and what we provide is a tool set that allows for operators to leverage all of those different types of inputs together in order to build a very, very precise understanding of where the hotspots are and where it's going to matter first to deploy small cells. Now, a third dimension I would add to that problematic is that as an operator, you may not want to focus on all traffic and all users. It may be your strategy to focus on certain type of traffic, on certain types of VIPs, to call it that way, whatever VIP means to you. And it can mean different things for different operators. In order to do that, you need to understand who your VIPs are, where they are, what they are doing, what services they are using. And you need to, again, be able to geolocate them very precisely. So that's also something we enable with our solution.
All right, Yann.
And that's something, sorry.
Oh, no, go ahead. I apologize. We had a bit of latency on the connection there, and I didn't mean
Yeah, nothing that as well. Sorry about that. So that's something we enable with our solution as well by monitoring 24/7 the usage on the network and all subscribers. And that allows for operators to build very accurate pictures of where their VIPs are and what they are doing, for them to then be able to focus their small cell deployment on them, on serving the VIPs throughout the network and making sure that they serve the subscribers they want to serve and the traffic they want to serve. So to answer your question, all those different inputs, I think, are fundamental in enabling operators to focus their deployment efforts on where it matters and what matters.
And finally, Yann, let's look down the road a little ways. How do you see small cells figuring into the telecom landscape over the next 5 to 10 years?
Because I see lots of efforts, lots of research, lots of standard bodies now embarking. 3GPP has started studying it, and I think there's a lot of activity around 5G. And whenever 5G happens, I think there are lots of evolutions of the technologies that are driven by 5G and are going to be fruitful before they even appear in a 5G labeled technology. There are different trends we are seeing. A first aspect I would mention, which might be more tactical than others, is that focus on indoor cells versus macro cells. I think a lot of operators must realize that there's a lot of value in optimizing what they have today before they go too far in deploying a lot of small cells. And even as they go about deploying small cells, especially inside the buildings, I believe there's a lot of gain to get from making sure that they optimize interference that are happening today between the window cells and the outdoor cells. And again, that's all about focusing on the 3D aspects of their design, which I think is something that is going to be more and more important. Now, looking into the technology itself, LTE Release 12 is bringing a lot of new potentialities. When they become available in actual offerings from the manufacturers is another question, but they're typically very fast in offering technologies after they're standardized. We are seeing evolutions with different features. One of them is the interference management for neighbor TDD cells. So that's another technology that is going to better enable small cells. We are seeing features like dual connectivity between the macro and the small cells. So it's the ability to have a UE that connects to both cells, typically using one frequency to anchor on the macro layer, and then using another frequency to boost the data rates from the small cell. So that's another enabling technology. We are seeing the notion of small cell on-off coming in release 12, which is very interesting. You could see it as simply an energy efficient load balancing kind of technique. But there's more to it, because let's remember that the small cell generates interference. Now, if a small cell is not sufficiently loaded, it can be very interesting to simply turn it off, switch its traffic to a macro layer, which can absorb it at the time, and therefore that's going to reduce the amount of interference the small cell is going to produce, which therefore will increase the capacity of the surrounding cells. So that energy efficient feature can actually be a capacity enabling feature as well. So that's another approach that's very interesting. We're seeing 256 QAM. So again, the ability to leverage the small cells to have more throughput in the cell. That works well when you're very close to the cell, in the cell that's not too loaded, low mobility. So there are lots of conditions, of course, to leverage it. But again, that's a feature that's coming. Now, looking beyond this, there are, of course, large evolutions in the backhaul network. And I would say backhaul, fronthaul, whatever it's called, and that entire evolution of the architecture of the backhaul towards CRAN, towards virtual RAN. So that's a domain where we're active as well from a service solutions point of view, especially, and that's a domain that I think is going to change fundamentally the architecture and the adoption and deployment of the small cells in the future. There are lots of other big trends. IoT is one, moving towards higher frequency, which enables larger antenna arrays. Lots of activities that I think going towards 5G is going to bring a lot of new innovation and new potential for operators to deploy small cells in a way that's very, very efficient.
All right, a very big thank you to Yann Le Helloco of InfoVista for joining us today. I'd also like to thank the folks at home for tuning in. For more great multimedia content as well as previous episodes of this program, you can visit the RCR TV website as well as our YouTube channel. And we'll see you right here next week for more HetNet Happenings.
HetNet Happenings is a production of RCR TV. To reach Sean Kinney or to suggest a show topic for HetNet Happenings, you can reach Sean at skinney@rcrwireless.com. On Twitter at Sean Kinney RCR. To find out more about the latest in HetNet and all things wireless, dig into rcrwireless.com.